Good morning. I cannot express strongly enough my joy in being able to address you all and my sadness of not being able to do so in person. I know that through the hard work of Alfred Chung of Neo Union ESC and Ben Galuzzo, the new executive director of COMAP, this meeting will be filled with wonderful ideas about the practice and utility of mathematical modeling, as well as ways in which modeling can best be presented to students and teachers alike. And make no mistake about it, this is also a celebration of this year's teams and 10 years of hard work to perfect and institutionalize the International Mathematical Modeling Challenge. I want to talk a little today about the history and philosophy of IMMC. I hope you forgive any inaccuracies. I may get a date or a place wrong, but not our goals and our underlying philosophy. First, it can't be stressed strongly enough that we are mathematics and modeling educators. COMAP has administered contests since the first MCM in 1985, and all of our contests are about educating students, about affecting real educational change. Our contests are a means to change the curricula and philosophy of how mathematics is taught and learned. IMMC must be understood in this context. Alfred and I first met in Boston and China in 2012 and 2013. We talked a great deal about mathematics education in general and mathematical modeling education in particular. By then, MCM had become a well-established international undergraduate competition and was attracting a large number of Chinese teams. High MCM was well on its way at the high school level. While there were and continue to be entries from some 20 additional countries and regions, these contests have been dominated by China and the US. We sought a different model. We settled on a version of the mathematical Olympiad model with a team perspective. In all of our contests and challenges, we have presented students with real problems, the sort of problems they might be called upon to analyze and solve in the workplace. And because we wanted students to have a real experience on how they might actually take part in their future use of mathematics, we made these true team experiences. It is most often the case that problems are in fact solved in teams, and we felt it important that students have that experience, often denied them in mathematics classrooms. And we believe that students can and should use all available resources to work on these problems. Doing the research to learn as much about a problem before tackling it is a key part of what we need to have to explain our solution to others. And we need some time, because unlike a mathematics test where speed is a major criteria, working on modeling problems requires time to truly understand the context of the problem as well as potential approaches. And there's never a single correct answer. As for the Olympiad model, we decided to allow each country and region to enter papers from up to 2 teams of 4 students each. We do not tell the participating countries or regions how to select those teams, although we encourage internal contests. The challenge problems are selected by our expert panel, of which Ben Galuzzo is chair. The entire contest is overseen by an organizing committee, which I am honored to chair. And against all odds, it works. When we began 10 years ago, we had 17 teams from 10 countries and regions. This past year, coming back from COVID, we had 68 teams from 38 countries and regions. and we insist that our problems are real problems that real people have to struggle with. From how to plan, schedule, and budget a movie, to how to afford to give awards for world records at a track meet, to deciding how many people the earth can sustain, students struggle with problems whose importance they can understand and appreciate. This is why I study mathematics, not simply to prepare for the next course. We know that there is much, much more work to do. Many of the discussions here in the coming days will be about how to grow these numbers, how to ensure that the contest and its underlying philosophy become institutionalized as the movement of mathematical modeling grows. IMMC is a small piece of a much bigger movement, but as the work here in Hong Kong and in several other parts of the world has shown, it is a powerful idea which can affect real and sustainable change.